Right, shed guy here. Welcome. I need to make a spanner. Spanner for the nut. So we'll take a piece of stock. Somewhere in there is a spanner. What I will do is I'll go for a ring design about that thickness round the outside. Bit of Dicam blue. Start the day with Dicam blue. Oh man, that smells nice. Drink some tea. You're in your shed. I'll be making pumps out of taps that are broke. Quite good fun actually. Right, pump it. Right, a new vernier. Inner diameter across the flats. Quite nice because you can read inches and millimetres easily on this one. There you go. Right, well I'm going to call that, say, 34.1, 17 on the radius, so inner radius 17, outer diameter should be about 1.5 inches. It is about 1.5 inches. So 3/4 inch. I'll use the chunkier ones as I get up the size of radius. Ooh, they're much easier to use. Big, chunky. Somewhere back in the day, these have come from Mr. Lawton. These skinny ones are brown and sharp, and they're a bit twangy in comparison. Very twangy in comparison. Okay, so what I'll do now is I'll look at that and I'll say I'll take that as an outer radius. Yeah, well that outer line's accurate, isn't it? Anyway, not to worry. Right, so this is where your didgeridoo comes in, because I'm just going to set that as a 0. Right, so going 14mm either side of that line. So that was plus 14 minus 14. Right, so this will go on the rotary table on the mill, and we'll put a, we'll actually mount it on a fixture plate on top of the rotary table. Okay, so that's just an accurate bushing that fits on this old tap, 1/4 inch shank. Okay, so I've used the bushing to centre up my fixture plate. I'm going to pump off through these holes so I can pick up the workpiece and bolt the workpiece straight through into some of these holes. So I'll transfer punch that. So I've done some centre pumps there. and I'll drill those through now. 1, 2, 3, and this is 5/16 tappings, so I use an 8mm drill. So I'll 8mm drill those there. Okay, so I went for 4 8mm drilled and reamed holes. This little bushing fits flush on the bottom of the rotary table, picks up on this boss, so that I can actually use a through bolt later on in the process. I'll flip the rotary table and centre it up on the milling table. Flipping Nora. Rotary table in. I'm just checking that we're true to the spindle. Alright, so that looks about good. And now we've got to get the table true to the bore. Got an ER25 collet of the correct size. So the rotary table is floating. So the rotary table's now dead true. Locked off. Okay, so true to the centre here is true to this. There you go, that's off. Comes off, that's what that collar's for, and that's why there's a ding on that collar. Right. This is 10-inch diameter, this fixture plate. Okay, so we've got a Morse taper 2 at the bottom. This is now riding on that shoulder. Lock the table. So now my fixture plate is concentric. There you go, there's your Morse taper, there's your bush to go in there. So this is now concentric with the table, concentric with the spindle. Happy days. What I've done is I've taken set of nuts that are all about the same height, and I've checked those. So I know those 4 are pretty much the same size, so I'm going to use those to space the work off my table. Okay, so providing we've been reasonably accurate, right, so we're picking up there, which is looking good. Yeah, we're looking nice. Right, we're calling that central. Just back those off a little bit so they're not working their way into the underside of the table. Right. Lock the table, nip those up. So my workpiece is centered here. It's good and tight. It's spaced. It's parallel. All right, so we're held here, 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 clamped here. We've got even spaces all the way around. Right, well, we've got the hole so big, so what we're going to do now is bore it. Yeah, that's my chunkiest boring bar there, so that'll go in. So let's have a look and see. Alright, so this is a universal boring head. What we're going to do is put a 2mm cut, moving the cutter that way. So it's taking 2mm off the diameter. So this is a Wohlhaupter universal boring head. Smoking! Okay, 2mm off the diameter. We're just going to keep working our way up. The cutter's going that way. So my work's got to go that way, so that it's coming into the cutter. Yeah, that's it. So I've got a tiny little FC3 cutter. It's held in a little adapter this time, up inside the collet chuck. Yeah, I've nudged up to the cutter. We're now cutting, just touching. So each of the teeth should have a flat. So we're going to come backwards and forwards, backwards and forwards. And then there should be a diameter cut out as well. And the depth of the cut is 80 thou. So I'll set this block here to 80 thou. Okay, here we go, 170 to 145. I am pulling the face of a man who is spinning a tiny cutter. Right, Up to a point that was going very well. We got the spacing correct. I did the maths incorrect on one of the numbers, but it wasn't far off. So we were getting 1, 2, 3, 4, 5, should have been 6, 7, 8 notches. I forgot to allow for the cutter diameter, which of course was small, but the minor mistake really was there should be 6 teeth, not 8. So right, back to the drawing board. I'm going to do it again. Nice pattern with the Dicam. Okay, so first time through, I cut too many slots and they were too narrow. So what we're going to do is cut 20 degrees, move 40 degrees. So we can see underneath, we've marked off, we know we can see the markers telling us where we are. As the rotary table goes round, we're going to be turning in this direction, which is turning the table towards us and into the cutter. And what that will give me is an orange chunk segment shaped tooth. So I'm going to go around, make my 6 orange segment teeth. Then what I'll do is I'll know where the centre line is. I'll move the table and do a straight cut, so I get a square tooth, and I'm going to cut down into the root, so I'll lose this radius here. And I've sort of worked out how much offset I've got to move. So alright, so that's looking pretty promising. We've been using a larger diameter cutter there, so we're going to swap out, go for the small cutter, and then we're going to make our square cuts. So that's your 7/64 coming out. That's the finest one I've got, which is your 5/64. Give it a go. Well, I've got finer, but it's not long enough to clear the thickness of the workpiece. Okay, so I'm on 225 degrees under here. I'm going to unlock the table. Okay, so I'm going to move the table away from me by 1, 6, 5, 50, 60, 5. So there's your 165. Lock it. And then we're going to cut to the stop. Okay, so I'm going to bring the table back to me. Here's the backlash. Coming back to my 0. So now we're going to come towards us by 165. And here we go. 50, 60, 5. Lock it off. Have a look. Put a cut on. Okay, so that's the first tooth. What I'm going to do is drop it down. And then have a look. I won't return it to 0 because I can make the next cut on this setting Okay, so what we've opted to do is just move the table, do my cuts on one side of the tooth. The first tooth was about the right width. Now I'm going to move the table the other way and do the other 6 cuts. It's just less moving of the table. Get it right, keep it right. We've gone round, we've worked our little 5/16 cutter into all little nooks and crannies, and I've gone round once and just put flats on these engaging faces. We are perilously close to that fitting, so I'm just going to go around. I've blued it up and just dust off probably the first 3 faces, see if my nut drops in, and then do the next 3 if not. Rightio. Okay, so I think my cutter was flexing a little bit as I went in to do the teeth. So, you know, when I dialed in to take 1/1000th, it sort of didn't quite do that. We've run the chamfer tool round the outside, round the edges. And there you go. Nice tight nut. So now what we'll do is we'll cut the outline of the spanner with a ripper cutter. Cutting the relief here made all the difference. Okay, so that was the tool I did the chamfering with, my chamfer tool, and that's going to be my ripper cutter. Okay, so we've centered up a drill, drilled a hole in here. If we wanted to radius that on that hole there, we'd have to move the whole job along. And put that on center. So I'll do that in a minute. Before I do that, I'm just going to put a little dink in either side. So workpiece centered up. Now put the cutter in, do an offset, and then turn the rotary table. Alright, so after all that, we've got the part made. That's a nice, decent fit on that nut. So I'm a happy man. And what I'm going to do now is just clean that up, polish it off. We shined it up a bit, and now, you know, you can see it sits on real nice. It'll go better that way because this side's we've relieved the corners so it really gets a proper sit down there. So there we go, smashing. Nice job on the Vertex HV6 rotary table with a fixture plate sat on the top, countersunk 5/16 hardware, really holding it tight. Just does very well. Thank you for watching. Shed Guy, gone.